Alright, folks. Hello, everyone. Welcome back to my SDET Interview Masterclass series powered by Lambda Test. If you've already watched episode 1, our beginner level deep dive, you now know the fundamentals. What an SDET really does, how to think like one, and how to work effectively with cross-functional teams. But now we are stepping it up. This is where things get more technical, framework-driven, and automation-heavy. At the intermediate level, interviewers expect you to go beyond theory. They want to see if you can think broadly, design, implement, and integrate automation solutions into real world software delivery processes. As most of you already know, I'm Siddhant Vadhwani, your guide come mentor through this episode to prep you with the interview questions and respond with the perfect answers. I'll be covering automation patterns like page object model and data driven testing, handling tricky UI situations like dynamic elements, integrating API testing into your frameworks, version control and branching strategy, techniques for automation, and lastly, how AI is transforming the way we maintain and expand test suites in 2025. And yes, as promised, I'll drop plenty of pro tips and code examples along the way. So you're not just memorizing answers, but actually understanding how to implement them in your work. So if you're ready to move from being a test executor to an automation problem solver, let's dive right into our first question. First up, dynamic elements. How would you handle dynamic IDs, changing locators, and general flakiness caused by front-end frameworks, especially the modern automation tools like Playwright or Cypress? Great question, right? This is one of the most common pain points. Dynamic elements are a common challenge, especially in React, Angular, or Vue.js based UIs, where IDs and attributes change on each render. The strategy here is threefold. Choose stable semantics, use robust locator patterns, and lastly, add resilience logic. So how I approach this is, firstly, prefer semantic locators. Always ask developers to add stable attributes like data-test ID or data-QA. They are explicit, stable, and meant for automation. If available, use role, area labels, or visible text, which are still better than brittle IDs. Second, robust locator patterns. In Playwright, I prefer role or text-based locators. You can use await page.getByRole, your button with the name continue.click. In Selenium, using Java, for example, you have web element button, driver.find element by.xpath. You have button normalize space continue.click. And same way in Cypress also, you have selectors that you should prioritize, whether it's the data test ID or data-CY, and the same format that you see in Playwright and Selenium. However, apart from these, you also have strategies like fallback strategies and utilities. You have resilience, no blind sleeps, and AI-assisted healing. Talking about the fallback strategies and utilities, you can write up a small locator util that tries multiple strategies, that checks first by data test ID, then area label, then text, and then a visual heuristic. When you talk about resilience, mainly focusing on no blind sleeps, use explicit wait patterns, network idle where appropriate, and retry only where meaningful. Idempotent actions, of course. For example, Playwright's wait for and assertions that auto wait are very helpful. And when we talk about AI assisted healing, in 2025, we have plugins that suggest alternate selectors if a test fails. Use that, but treat AI suggestions as candidates. Review and add it to your fallback list. So, pro tip here is maintain a small glossary in your repo, mapping business actions to selectors. Example, you have checkout.submit button, data-test ID equal to checkout-submit. It makes debugging and cross-team discussions much faster. Nice. Now let's talk about structuring that code using page object model. So what is page object model? Is it still relevant? If yes, how do you structure it in today's world? So let's look at some best practices. Absolutely. POM is still relevant, but it's evolved. The core idea and fundamental remains, separating the test logic from the UI structure, making maintenance much easier. Let's look at some modern changes. talking about component-based page object models. With component-driven front ends or micro front ends, create reusable component classes, example, header, model, and compose pages from these components. Type safety and IDE ergonomics. Use TypeScript or strong typed classes so you get auto-completed and safer refactors. Small composable methods. Prefer fill login form user over exposing low-level selectors in tests. Keep page objects declarative. AI-generated scaffolding. Use AI to scaffold page objects quickly, but always refactor for readability and reuse. And last but not the least, test maintainability. Centralize the locators, selectors, configs, and common utilities like retry policies or wait helpers. Keep page object models small and focused, and add test to guard refactors of page object models themselves, maybe meta tests. So pro tip here is keep the page object model classes deterministic and stateless where possible. Avoid storing ephemeral state inside page objects that can confuse parallel runs. Let's talk about data-driven testing. Data-driven testing is about separation of data and logic and makes use of reusable uh, test data across datasets. So how would you implement data-driven testing in your automation framework? Well, I can relate it with multiple sources of data that I fetch from local, remote, APIs, or synthetic data. Local in the form of whether it's JSON or through CSVs, Excel, they are quick drives for small suites. Remote could be in the form of S3 buckets, GCS hosted JSON, or DB snapshots for larger datasets. APIs to call a test data provisioning API that returns ephemeral test entities. And lastly, synthetic data, which you can make use of Faker or AI to generate edge case data in the form of Unicode characters, very large strings, boundary numbers, and so on and so forth. Talking about implementation, we can take examples of Playwright or several other frameworks that help in this regard. So let me consider example of Playwright. You take const user as require users.json, you're fetching the value from there, and then you run a for loop where you have your username and the password that's being captured from the login page. And then you ask it to navigate and check if it's redirecting you to the dashboard page. So a simple script like that, where you're fetching all this username password information from the DB itself. You also have best practices. So make use of idempotent test data or ephemeral resources. For example, create and destroy per test. That is test setup, test teardown. Mask or synthesize production data for privacy compliance. And lastly, use transactions or DB snapshots to reset state fast in integration tests. You also have test data orchestration, where you have orchestration scripts that seed environments. So you can create a Terraform plus SQL seed or API seeders. For large scale suites, orchestrate test data provisioning in CI so each parallel runner gets unique data to avoid collisions. A pro tip here is combine those data driven tests with test impact analysis so you run combinations only when they are necessary. Too many combinations explode runtime. By the way, here I've implemented a data-driven login test using Playwright's native for each approach with imported test data. Let's say we want to test a login feature with multiple username password combinations stored in the below JSON file. You can see I have username, admin user, test user, guest user, and different passwords for those. And I want to test our script with these combinations. So instead of writing 3 separate test cases, I store all credentials in a JSON file and iterate over them. This makes the test scalable and maintainable. Adding a new dataset is as simple as adding another object to the JSON array. The test.describe that you see here block groups all related tests under one heading in the report. Each dataset gets its own dynamically generated test name like login with admin user. Playwright automatically runs each test block independently, so a failure in one dataset won't block the others. And for validations, I'm adding conditional assertions. For example, the admin user should see a welcome admin message, while invalid credentials trigger an alert. This approach has several benefits. It reduces code duplication by reusing test steps, makes test maintenance easier. If the login UI changes, I update the selector in one place. And lastly, it allows integration with external data sources, like whether it's CSV files, databases, or APIs for live test data. A pro tip here, in CI/CD pipelines, I sometimes parameterize the data file path so I can run smoke tests with minimal dataset, all without changing the code. How do you test REST APIs and integrate those in your automation framework? Now, as most of us already know, API testing is foundational. So here's a layered approach. Start off with contract or schema tests. Validate against OpenAPI, Swagger, or JSON schemas. These catch breaking changes quickly. Second, functional tests. Assert status codes, response bodies, fields, and business rules. Negative and edge cases. You have the 4XX, 5XX flows, timeouts, mild form payloads, etc. If we talk about non-functional areas like performance and load test, you can also test for latency, the throughput, and concurrency checks. You can make use of JMeter, Locust, K6, Gatling, many others. Next, where to place these API tests. So you have unit level contract tests, which live with the services near the code. You have integration or contract level test data that can run in CI as part of your PR checks. And finally, you have some end-to-end APIs and performance tests that run in nightly pipelines or pre-release gates. Don't forget some automation tips here. Run API tests early. Probably follow the shift left approach here because they're fast, deterministic, and catch a lot of issues before the UI tests run. So quick pro tip again, generate mocks from OpenAPI during development. So frontend can be tested independently. Also, push API test results to dashboards, whether it's Allure, report portal, or any dashboard that you use for traceability. What's your approach to version control and branching for automation code? Version control is a critical part of managing automation code. How do you approach it, and what branching strategies do we follow? So for automation code, I treat it exactly like application code because it's a first-class citizen in the SDLC. That means applying Git-based workflows, proper branching strategies, and PR reviews to maintain quality. My go-to approach would be using Git flow for larger teams and a trunk-based development variant for fast-paced CI/CD projects. In Git flow, I keep the main and master branch as one, always stable, production ready automation code that relies and stays there. I also have a develop branch, which is used more for integration as part of merging multiple codes to make the features work. And lastly, I have the feature branch where it's one branch per automation feature or ticket. For example, you can think of feature slash API test, feature slash login, a POM refactor, and likewise. When following trunk-based development, I keep feature branches short-lived, no more than a couple of days, and rely on feature toggles in the automation framework so incomplete tests don't break the CI pipeline. Pro tips that I follow here is small, frequent commits with meaningful messages. Make sure you're deleting the branches. Use git commit -m with proper initial messages. That is much better than fix or changes, right? Second, pull request templates. We have a PR checklist for automation code, including test naming convention, the DRY, don't repeat yourself principle check, um, various other principles, and screenshot video verification for UI flows. Third, code reviews with at least one other estate, like a peer review. This catches locator brittleness, framework, anti-patterns, and missing edge cases early on. Fourth, branch protection rules. Now your CI pipeline must pass before merging to main. No direct commits should be allowed. And lastly, the tagging and release processes. We tag stable automation versions so we can always rerun historical suits against a given app version. And where you have multiple repo setups where automation and application code are separate, I sync version through semantic versioning. For example, version 2.3.1 hyphen automation, that is the version that it should use to run those stable set of tests. And what about Gen AI assisted automation? I make sure generated test scripts are committed in a separate branch first for human review. AI can help speed up writing locators or boilerplates, but code quality checks remain manual. Ultimately, the goal is zero broken builds on main or master branch, fast feedback via CI, and clear traceability from commit to PR to test execution to deployment. Last and final question: how can AI improve test case coverage and maintenance? We all know AI is becoming a bigger part of QA. So in 2025, AI in QA has matured well beyond just generating random test scripts. We now use agentic AI and LLM powered tooling to continuously monitor, generate, and update tests. For improving test case coverage, let's talk about that. We have intelligent gap analysis. Here, AI can analyze code changes, pull request differences, and production logs to detect untested flows and suggest new test cases. For example, a tool like Launchable or TestM with AI Insights can scan your code base, find untested conditional branches, and auto-generate Gherkin scenarios for missing paths. Second, user behavior mining. AI can also use itself to study analytics, data, and real-world click streams to create test cases for the most used and most error-prone features, improving the risk-based coverage. Lastly, many of you might have heard model-based testing. AI agents can crawl your application, map the DOM structure, and auto-generate a model of possible navigation paths, then produce test cases to cover each route. And when we talk about maintenance, we have self-healing locators. AI can detect UI changes and automatically update those selectors in your automation scripts without manual intervention. For example, if a button's ID changes from hash submit to hash confirm BTN, AI can infer from context that it's the same element and update the locator. Impact-based test selection. Instead of running the full suite on every build, AI can predict the smallest set of tests that cover the latest changes, cutting CI time by almost 60 to 80%. Natural language maintenance. With tools like OpenAI's API integrated into our frameworks, you can say update login test to include OTP flow, and AI will refactor the test class while preserving the framework conventions. So my pro tips from this experience is pair AI generated scripts with human review. AI is definitely great for speed, but context matters. Feed AI models with your team's historical defect data. This trains it to target the kind of bugs your product is prone to. Keep an audit log of all AI generated changes for traceability in regulated industries. All right, let's wrap up our intermediate SDET deep dive. Today we covered some must-know skills that separate a beginner from a confident mid-level SDET. That is, how to build robust locators to make your automation stable and resistant to UI changes. Relevance of POM with modern enhancements. Building data-driven test, turning one script into dozens of parameterized test scenarios. Managing API automation, and even code-first approaches for scalability and maintainability. Applying smart version control and branching strategies so your automation code base stays clean, traceable, and CI ready. And last but not the least, leveraging test analytics to fine-tune coverage, reduce the redundancy, and improve execution speed. So thank you everyone for staying with me until here. An intermediate SDET isn't just writing tests. They are designing them for longevity, maintainability, and deep-wide collaboration. Next up, our Advanced SDET episode, where I'll go beyond frameworks into scalable automation design patterns, performance testing, handling test flakiness, AI-based use cases for testing, and how do we leverage generative AI and agentic AI into DevTestOps pipeline integration. So if you found this valuable, drop a comment with your biggest takeaway from today's session, and don't forget to like, follow, and share so you don't miss the advanced level knowledge bombs.